Alright, let's go. Number 10. Mars. In November 2021, NASA's Perseverance rover captured something unusual in the Martian sky. Clouds of frozen carbon dioxide drifting through an atmosphere that's 96% the same gas. This is where you'd last the longest without protection among all the planets in our solar system. But longest is relative when you're standing on the surface of another world. Mars offers the most forgiving environment beyond Earth, if such a word can even apply to a place where the average temperature hovers around negative 81 degrees Fahrenheit. The atmospheric pressure is just 0.6% of Earth's, meaning your blood would begin to boil at body temperature. The gravity, at 38% of what you experience on Earth, would feel almost liberating at first. You could jump 3 times higher than normal. Your muscles would feel powerful, efficient, unburdened. But that freedom comes with a cost written in seconds. Without a spacesuit, you'd have perhaps 90 seconds of consciousness if you held your breath, preventing your lungs from rupturing in the thin atmosphere. The cold would creep through your skin with unsettling speed. The lack of oxygen would trigger hypoxia, your vision would tunnel, your thoughts would scatter, and a strange euphoria would wash over you as your brain began to shut down. The reddish dust beneath your feet would be the last thing you'd see clearly. What makes Mars particularly haunting is how close it comes to being survivable. Of all the worlds in our solar system, this is the one where human engineering might actually create permanent settlements. The day length is nearly identical to Earth's at 24 hours and 37 minutes. Water ice exists beneath the surface. The soil could theoretically support plant growth with proper treatment. Mars gives you the gift that no other planet offers. Time. Not much. Perhaps 90 seconds of consciousness before the cold and pressure differential claim you, but enough to witness an alien sky before your body succumbs. In those final moments, would you see something that might change how we understand our place in the universe? Or would you simply see the inevitable end that awaits anyone foolish enough to stand unprotected on another world? Number 9. Mercury. In March 2011, NASA's Messenger spacecraft became the first probe to orbit Mercury, revealing a world of impossible extremes. The day side reaches 800 degrees Fahrenheit, while the night side plunges to negative 290 degrees, a temperature swing of over 1,000 degrees Fahrenheit. Standing on the line between day and night, you'd experience both deaths simultaneously. Mercury has no atmosphere to distribute heat across its surface, creating the most extreme temperature differential of any planet in the solar system. The sun appears 3 times larger in Mercury's sky than it does from Earth, blasting the day side with solar radiation intense enough to melt lead. Yet just a few miles away on the night side, temperatures drop low enough to freeze oxygen into pale blue crystals. The planet rotates so slowly that one day on Mercury lasts 59 Earth days, creating a Terminator line, the boundary between light and dark, that crawls across the surface with agonizing slowness. If you somehow stood on this twilight boundary, your body would become a battleground between opposing forces. The side facing the sun would begin to cook, your skin blistering and charring as moisture evaporated from your tissues. The side facing away would freeze solid, ice crystals forming in your blood and cells. The gravity, at just 38% of Earth's, would provide no comfort. You'd feel light on your feet even as thermal shock tore you apart. Your lungs would collapse in the vacuum. Your eyes would freeze on one side while boiling on the other. What makes Mercury's Terminator particularly unnerving is the possibility of a zone, perhaps just a few feet wide, where temperatures might briefly hover near Earth normal levels. For a fraction of a second, as heat from one side and cold from the other achieved equilibrium, you might experience the most comfortable temperature any human has felt on another world. Then the balance would shift, and both extremes would consume you. Mercury demonstrates the universe's indifference to human survival in the starkest possible terms. One side roasts, one side freezes, and somewhere between them exists a thin line where temperatures might feel almost Earth-like. It's the closest thing to comfortable temperature on one of the most inhospitable worlds in our solar system, existing only in the eternal twilight between extremes. A cruel joke played by physics on anyone desperate enough to stand there. Number 8. Uranus. On January 24th, 1986, Voyager 2 flew past Uranus and captured something bizarre. A planet tilted on its side, rolling through space with its poles positioned where most planets have equators. This 98-degree axial tilt creates seasons lasting 21 years each, a consequence of some ancient cosmic collision that nearly destroyed the planet. You wouldn't live long enough to see winter arrive, but your frozen body might endure for billions of years. Uranus exists in the outer solar system, over 18 times farther from the sun than Earth, where temperatures drop to negative 371 degrees Fahrenheit. The atmosphere is composed primarily of hydrogen and helium, but it's the 2% methane that creates the planet's distinctive blue-green hue. This methane absorbs red light from the sun, reflecting back those cold cyan wavelengths that make Uranus appear so alien. The planet's extreme tilt means that, for decades at a time, one pole faces the sun directly, while the other remains in complete darkness. These aren't seasons as we understand them. They're geological epochs of light and shadow. If you somehow reached Uranus Uranus, the cold would kill you before you'd fallen very far into the atmosphere. The temperature is so extreme that it challenges our everyday understanding of thermal physics. At negative 371 degrees, molecular motion slows to a crawl. Your body heat would radiate away within seconds. But before you froze solid, something stranger would happen. The methane in the atmosphere would begin to crystallize on your exposed skin, creating a thin layer of blue-green frost. Your tissues would take on that same cyan hue as methane ice formed in the moisture of your eyes, your mouth, your lungs. The gravity on Uranus is 89% of Earth's, meaning you'd feel almost normal weight even as you succumb to the cold. Wind speeds reach 560 miles per hour in the upper atmosphere, though by the time hypothermia set in, you wouldn't feel them anymore. Your body would tumble through the hydrogen atmosphere, acquiring layer after layer of methane ice until you resembled a frozen comet, blue-green, crystalline, forever falling toward a core you'd never reach. Uranus rotates on its side because of an ancient collision that occurred over 4 billion years ago, an impact so violent it fundamentally changed the planet's orientation in space. Your body would roll through that same extreme tilt, frozen solid and tinted blue-green from methane ice, a testament to cosmic violence that echoes through deep time. What happened to the object that struck Uranus? Did it shatter into the rings we see today, or did it merge with the planet's core, forever entombed in ice and pressure? Number 7. Neptune. In August 1989, Voyager 2 detected something on Neptune that defied physics. Winds screaming at 1,200 miles per hour, faster than the speed of sound, and the strongest winds measured anywhere in the solar system. For comparison, Earth's most powerful hurricanes barely reach 200 miles per hour. These are supersonic storms, on a planet that receives only 1/900th the sunlight Earth does. You'd be torn apart by forces that shouldn't even exist on a world this far from the sun. Neptune orbits nearly 3 billion miles from the sun, in the frozen outer reaches of the solar system, where temperatures drop to negative 373 degrees Fahrenheit, the coldest surface temperature of any planet. The atmosphere is primarily hydrogen and helium, with trace amounts of methane that give Neptune its deep azure color. But it's not the composition that baffles scientists, it's the energy. Neptune radiates 2.6 times more energy than it receives from the sun, meaning something in its core generates enough internal heat to drive weather patterns more violent than anything on Jupiter, despite being 4 times farther from the sun. Your death on Neptune would be extraordinary in its violence. The supersonic winds would hit you first, moving faster than your nervous system could process. At 1,200 miles per hour, atmospheric friction would generate enough heat to ignite your clothing even at temperatures hundreds of degrees below zero. The wind would shred your body into microscopic particles within milliseconds, dispersing your remains across thousands of miles of Neptune's atmosphere before the cold could freeze you solid. The gravity is 14% stronger than Earth's, meaning you'd feel heavier even as the winds disintegrated you. What makes Neptune's fury particularly unsettling is the Great Dark Spot, a storm system larger than Earth that Voyager 2 photographed in 1989. By 1994, when the Hubble Space Telescope looked for it again, the spot had vanished completely. Storms on Earth last days or weeks. Jupiter's Great Red Spot has raged for over 400 years, but Neptune's storms appear and disappear on timescales we don't understand, driven by internal heat sources whose origin remains mysterious. Neptune shouldn't have the strongest winds in the solar system. It's too far from the sun, too cold, too distant from any obvious energy source. Yet something in its core generates enough heat to drive atmospheric chaos that exceeds every other planet. Your shredded remains would circle that blue giant forever, unable to answer the question, what powers Neptune's impossible fury? What mechanism could turn a frozen world at the edge of the solar system into the most violent atmospheric environment we've ever measured? Number 6. Saturn. In September 2017, NASA deliberately crashed the Cassini spacecraft into Saturn's atmosphere after 13 years of studying the ring giant. The probe lasted just 93 minutes before being crushed and vaporized by atmospheric pressure that increased exponentially with depth. It was a titanium and aluminum spacecraft designed to withstand the vacuum of space and the radiation of Jupiter's magnetosphere. You're made of flesh and water. You wouldn't last a fraction of that time. Saturn is the second largest planet in our solar system, composed almost entirely of hydrogen and helium with no solid surface to crash into. The atmospheric pressure at what we consider the cloud tops is roughly equal to Earth's, but that pressure increases rapidly as you descend. Within the first 100 miles, pressure rises to hundreds of times Earth's atmosphere. Deeper still, still, the pressure reaches millions of times what we experience at sea level, enough to fundamentally alter the behavior of matter itself. The temperature similarly increases from negative 218 degrees Fahrenheit at the cloud tops to thousands of degrees in the depths, creating conditions that exist nowhere on Earth. If you fell into Saturn, you'd initially experience something deceptively gentle. The gravity at the cloud tops is just 6% stronger than Earth's, so you'd barely notice the difference. The upper atmosphere would seem thin, almost breathable if it contained oxygen instead of hydrogen, but as you descended, everything would change. The air would thicken around you, growing denser with each passing second. Breathing would become impossible first, not because of lack of oxygen, but because the hydrogen atmosphere would grow so thick that your lungs couldn't expand against the pressure. Within minutes, the pressure would begin to liquefy your tissues. Your body is roughly 60% water, and water's behavior changes dramatically under extreme pressure. As the atmospheric density increased, the distinction between gas and liquid would blur. You'd essentially be drowning in an atmosphere that had become as thick as water, then as thick as syrup, then denser still. Your bones would compress, your organs would collapse, and eventually the carbon in your body would begin to separate out under pressures measured in millions of atmospheres. Saturn has no surface to crash into. You'd fall for hours, watching the hydrogen atmosphere grow thicker, darker, more oppressive, as light from above faded to nothing. The pressure would liquefy your tissues, compress your bones, and eventually, far below where Cassini's signals died, transform what was once human into something else entirely. At depths where pressure exceeds 1 million atmospheres, hydrogen itself becomes metallic, conducting electricity like copper. What would happen to the carbon in your body at those same pressures? Could Saturn's core be surrounded by a thin layer of diamond compressed from every organic molecule that ever fell into it? Number 5. Venus. On December 15th, 1970, the Soviet Venera 7 probe became the first spacecraft to transmit data from Venus's surface. It survived for 23 minutes before the heat and pressure destroyed its titanium pressure sphere. That's the record for any human-made object on the surface of Earth's evil twin. The spacecraft was engineered to withstand pressure 92 times greater than Earth's atmosphere, equivalent to the pressure experienced 3,000 feet underwater. You'd have seconds, not minutes. Venus is nearly identical to Earth in size and mass, earning it the designation of Earth's twin. But the resemblance ends there. The surface temperature reaches 864 degrees Fahrenheit, hot enough to melt lead, and maintained constantly by a runaway greenhouse effect. The atmosphere is 96.5% carbon dioxide, trapping heat with such efficiency that Venus is hotter than Mercury despite being nearly twice as far from the sun. The atmospheric pressure at the surface is 92 times Earth's, meaning every square inch of your body would experience crushing force equivalent to being half a mile underwater. Above the surface, clouds of sulfuric acid rain down continuously, though the acid vaporizes before reaching the ground due to the extreme heat. If you somehow reached Venus's surface, multiple deaths would claim you simultaneously. The pressure would begin crushing you the moment you entered the atmosphere, your body compressing like a deep-sea diver who'd lost their pressure suit. Your lungs would collapse immediately. But before the crushing was complete, the heat would begin its work. At 864 degrees, your tissues would start to break down at the molecular level. Proteins denature, cell membranes rupture. Water in your cells would flash to steam, causing your body to essentially explode from the inside, while simultaneously being compressed from the outside. The Soviet Venera missions achieved something extraordinary. They captured actual photographs from Venus's surface before their landers were destroyed. Venera 13, which landed in 1982, survived for 127 minutes and transmitted color images showing flat rocks and soil tinged orange by the atmosphere. These are the only photographs ever taken from the surface of another planet besides Mars, and they show a world that's hauntingly Earth-like in appearance despite being utterly uninhabitable. The rocks look like they could be from Arizona or Nevada, but the temperature would liquefy you. Venus is Earth's twin in size, but it shows us our planet's potential future. What happens when a greenhouse effect runs wild? When oceans evaporate and carbon dioxide accumulates beyond any possibility of reversal? You wouldn't just die on Venus. You'd liquefy, your body chemistry breaking down at the molecular level while being crushed flat by pressure that would turn your bones to powder. Billions of years ago, Venus likely had liquid water in conditions similar to early Earth. This is how our world could look if carbon emissions continue unchecked, and your dissolved remains would be the warning no one would survive to see. Number 4. Jupiter. In December 1995, NASA's Galileo probe descended into Jupiter's atmosphere, transmitting data for 57 minutes before being crushed and vaporized. The probe was traveling at 106,000 miles per hour when it hit the outer atmosphere and had to survive deceleration forces equivalent to 230 times Earth's gravity. It made it about 100 miles down before the pressure exceeded 400 atmospheres and temperatures reached 3,000 degrees. The probe was a titanium sphere designed by the best best engineers at NASA. You wouldn't make it past the cloud tops. Jupiter is so massive that it contains more matter than all other planets, moons, asteroids, and comets in the solar system combined. It's often called a failed star. If it had accumulated just a few dozen times more mass during the solar system's formation, nuclear fusion would have ignited in its core and we'd be living in a binary star system. The gravity at Jupiter's cloud tops is 254% of Earth's, meaning you'd weigh more than twice your normal weight even in the upper atmosphere. But gravity is just the beginning. As you descend, atmospheric pressure increases exponentially. At the depth where Galileo was destroyed, the pressure was 400 atmospheres. Continue deeper, and it reaches thousands, then millions of times Earth's atmospheric pressure. If you fell into Jupiter, the descent would be a journey through states of matter that challenge our understanding of physics. Initially, you'd fall through hydrogen and helium gas, not unlike the air on Earth, just thicker and heavier. Your body would weigh more than twice normal, making every movement exhausting. But you'd quickly reach depths where the atmosphere becomes so dense that calling it gas no longer makes sense. The hydrogen would grow thicker and thicker until it behaved more like liquid than gas, yet never making a discrete transition between the two states. You'd be drowning in atmospheric pressure, your lungs unable to expand, your body compressing under forces measured in tons per square inch. Continue deeper still, far beyond where human consciousness would end, far beyond where Galileo's signals died, and you'd reach a layer where pressure exceeds 1 million atmospheres. At this depth, hydrogen stops behaving like a gas entirely and becomes metallic hydrogen, a state of matter that conducts electricity like copper and exists nowhere naturally on Earth. Laboratory experiments have only briefly created metallic hydrogen under extreme conditions. In Jupiter's depths, it exists as an ocean thousands of miles deep, surrounding a core that might be made of rock and metal, or might be something else entirely. But here's what makes Jupiter truly haunting. What happens to carbon under those same extreme pressures? You are a carbon-based life form, and carbon exhibits remarkable properties under compression. Laboratory experiments have demonstrated that at pressures exceeding 1 million atmospheres and temperatures of thousands of degrees, conditions that exist deep in Jupiter's interior, carbon crystallizes into diamond. Your body wouldn't just be destroyed. It would be fundamentally transformed, compressed beyond recognition, with every carbon atom in your bones, your DNA, your proteins potentially crystallizing into the hardest substance known to physics. Jupiter's core might be surrounded by a thin layer of diamond, compressed from every organic molecule that ever fell into it across billions of years. Cosmic carbon, frozen into crystalline form by forces beyond human comprehension. In Jupiter's depths, you wouldn't die. You'd become something else entirely. Your atoms rearranged into structures that might persist for billions of years, long after Earth itself has been consumed by the dying sun. Number 3. HD 189733b. In October 2005, astronomers discovered an exoplanet orbiting the star HD 189733, located 63 light-years from Earth in the constellation Vulpecula. This gas giant, slightly larger than Jupiter, appeared unremarkable at first, just another hot Jupiter orbiting close to its parent star. Then, in 2013, the Hubble Space Telescope conducted spectroscopic analysis of the planet's atmosphere and detected something unprecedented: silicate particles suspended in supersonic winds that exceed 5,400 miles per hour, 7 times the speed of sound. Hot Jupiters are gas giants that orbit extremely close to their stars, completing full orbits in just days rather than years. HD 189733b circles its star once every 2.2 Earth days, at a distance of just 2.9 million miles, only 3% of the distance between Earth and the Sun. This proximity creates surface temperatures around 1700 degrees Fahrenheit, hot enough to melt rock. The planet is tidally locked, meaning one side perpetually faces the star while the other remains in eternal darkness. This creates a massive temperature differential that drives wind patterns of extraordinary violence, far exceeding anything measured in our solar system, even surpassing Neptune's record-breaking storms. If you somehow reached HD 189733b, death would come in layers, each more horrific than the last. The temperature would begin cooking your tissues immediately, your skin blistering and charring within seconds. But the heat would be the least of your concerns. The winds, moving at Mach 7, would hit you with kinetic energy beyond anything experienced on Earth. At that velocity, atmospheric friction would generate additional heat even in the thin upper atmosphere, potentially igniting your clothing. But what makes this planet truly nightmarish is what those winds carry. The spectroscopic analysis revealed that silicate particles, essentially glass, condense from gaseous form at high altitudes, then get caught in the supersonic wind streams. These aren't ordinary dust particles. They're microscopic shards of glass, formed from silicon and oxygen vaporized from rock, condensed in the cooler upper atmosphere, and accelerated accelerated to 7 times the speed of sound. Each particle would impact you with the kinetic energy of a rifle bullet. You'd be simultaneously roasted at temperatures hot enough to melt rock, shredded by winds moving faster than most fighter jets, and pierced by thousands of glass fragments moving at hypersonic velocities. The question isn't what would kill you first. It's whether any recognizable piece of your body would remain intact long enough to register the other deaths. On Earth, glass is fragile, decorative, something we use for windows and drinking vessels. On HD 189733b, it's a weapon traveling at 7 times the speed of sound, each microscopic shard carrying enough energy to penetrate bone. This planet represents what happens when familiar elements, silicon, oxygen, atmospheric currents, combine under alien conditions to create something horrifically novel. Your body would be shredded into a red mist, then instantly vaporized by heat, the glass continuing to circle the planet forever in those supersonic winds, each shard carrying microscopic traces of what you were, preserved in silicate for millions or billions of years. Number 2. Wasp 12b. On April 1st, 2008, astronomers using the Super Wasp survey discovered Wasp 12b, an exoplanet so close to its star that it's being actively devoured in real time. The planet orbits just 2.1 million miles from its parent star, 50 times closer than Earth is to the Sun, close enough that its orbital period is only 1.09 Earth days. At this distance, the star's immense gravity stretches Wasp 12b into an egg shape, pulling away an estimated 189 quadrillion tons of the planet's mass every year. This isn't a stable system. Scientists calculate that Wasp 12b has less than 10 million years remaining before it's completely consumed. When planets form, they typically settle into stable orbits where gravitational forces balance with orbital velocity. Wasp 12b represents the opposite, an orbit so close that tidal forces are literally tearing the planet apart. The surface temperature reaches 4,600 degrees Fahrenheit, among the hottest known exoplanets, hot enough to vaporize most metals. The star's gravity creates tidal bulges on Wasp 12b, similar to how the moon raises tides on Earth's oceans, except these tides are made of gaseous atmosphere being pulled away from the planet entirely. This stripped material forms a disk around the star, similar to Saturn's rings, but composed of planetary atmosphere rather than ice particles. The planet is being converted into a diffuse cloud of atoms, gradually spiraling into the star that's destroying it. If you reached Wasp 12b, you'd arrive at the boundary between planet and star, where definitions blur and matter exists in transitional states. The temperature would exceed 4,600 degrees, hot enough that thermal radiation alone would vaporize exposed organic tissue instantly. Your water content would flash to superheated steam. Your carbon and other elements would begin to ionize, electrons stripped away by the extreme thermal energy. But the temperature would only be the first stage of destruction. The tidal forces stretching Wasp 12b would begin stretching you as well, though at the atomic level. The gravitational differential between your head and feet, normally negligible on Earth, would become measurable, then significant, then overwhelming. Astrophysicists call this spaghettification, the process by which objects are stretched into long, thin shapes by tidal forces. You'd be pulled apart lengthwise while simultaneously being compressed from the sides, your body gradually transforming from three-dimensional form into an increasingly thin stream of ionized particles. This isn't metaphorical. Your atoms would literally be pulled away from each other, joining the stream of planetary atmosphere being stripped away and fed to the hungry star. Wasp 12b is doomed, its fate sealed by gravitational physics that cannot be reversed. Every orbit strips away more of its mass, feeding it to the star in a cosmic act of slow-motion cannibalism that will continue for millions of years. If you somehow reach this planet, you wouldn't just die. You'd become part of the star itself, your atoms pulled across millions of miles of space, ionized into plasma, and eventually absorbed into the stellar fusion reactions occurring in the star's core. In 10 million years, Wasp 12b will be completely gone, its entire mass consumed. But the photons created by fusing your hydrogen atoms would travel across the universe for billions of years afterward, the longest lasting trace of your existence that physics allows. Light-speed particles carrying the energy signature of what you once were to distant galaxies you'll never see. Number 1. Gliese 436b. In August 2004, astronomers discovered a Neptune-sized exoplanet orbiting the red dwarf star Gliese 436, located 30 light-years away in the constellation Leo. Initial observations suggested it was a typical hot Neptune, a gas giant orbiting close to its star, with a relatively standard composition. Then in 2007, detailed analysis of the planet's density revealed something that shouldn't be possible according to our understanding of physics. Gliese 436b is a planet made of burning ice, water compressed so intensely by gravity that it remains solid at temperatures exceeding 800 degrees Fahrenheit. This violates every principle about phase transitions that we teach in high school chemistry. Water freezes at 32 degrees Fahrenheit and boils at 212 degrees under under Earth's atmospheric pressure. These aren't arbitrary numbers. They represent fundamental transitions in how water molecules arrange themselves. Solid ice occurs when molecules lock into crystalline structures. Liquid water flows when those structures break down. Water vapor forms when molecules gain enough energy to escape intermolecular bonds entirely. Temperature and pressure determine which phase exists. Except on Gliese 436b, they don't. The planet's mass creates gravitational pressures exceeding 70 gigapascals, 700,000 times Earth's atmospheric pressure. At this pressure, water cannot boil no matter how hot it becomes. The molecules are physically prevented from separating by the immense gravitational compression, creating a state of matter called Ice X that cannot exist anywhere on Earth's surface. Ice X represents one of several exotic high-pressure ice phases discovered only through laboratory experiments and theoretical physics. On Earth, we encounter only Ice I, the familiar frozen water that forms in winter and fills our freezers. But under extreme pressures, water molecules can arrange into at least 17 different crystalline structures, each designated with Roman numerals. Ice X forms at pressures above 70 gigapascals, where hydrogen bonds become symmetrized, meaning the hydrogen atoms are positioned exactly midway between oxygen atoms, rather than closer to one or the other. This creates a crystalline lattice, more rigid than diamond, held together by forces so powerful that thermal energy cannot disrupt it. The result is ice that remains solid at temperatures that would normally vaporize water. Ice that can glow red hot yet never melt. Ice that defies our fundamental understanding of matter. If you somehow reach Gliese 436b, your death would transcend conventional categories of burning or freezing. The temperature would be 800 degrees, hot enough that you'd expect to combust instantly like paper in a furnace. But the pressure would be so extreme that your body's water content, 70% of your mass, including blood, cellular fluid, and the water molecules integrated into your very DNA, couldn't vaporize. Instead, it would be forced into crystalline arrangement. Even as thermal energy coursed through it, you wouldn't melt, you wouldn't boil, you wouldn't vaporize. You would crystallize at high temperature, every water molecule in your body locked into the same rigid lattice structure found in Ice X, creating a state of being that has never occurred in Earth's biological history. The physics of your transformation would progress in stages. First, the atmospheric pressure would crush you, compressing your tissues until water could no longer flow. Your blood would stop moving, not because your heart failed, but because the fluid itself would be compressed beyond the ability to flow through vessels. Simultaneously, the temperature would begin breaking down organic molecules, proteins denaturing, and cell membranes rupturing. But the water, your water, would undergo a different transformation entirely. Under 70 gigapascals of pressure, it would crystallize into Ice X even at 800 degrees, forming lattice structures more rigid than any material naturally found on Earth. You'd become a statue of impossible ice, frozen solid, yet glowing red from thermal energy, your crystalline form maintaining perfect human shape, while radiating heat like a forge. This state challenges the very concept of death as we understand it. On Earth, death involves decay, decomposition, the gradual breakdown of organized structures into chaos. But on Gliese 436b, the extreme pressure would preserve your Ice X form potentially forever. The crystalline water forming your cellular structure would be locked in place by pressures that cannot be overcome by thermal motion. You'd remain frozen, still recognizably human in form, while radiating enough heat to glow in the darkness, a burning ice sculpture of what was once a living being, preserved in a quantum state that shouldn't exist, according to every rule we've established about how matter behaves. Ice X represents a state of matter so extreme, it challenges our fundamental understanding of chemistry and physics. On Earth, ice melts at 32 degrees Fahrenheit, a fact so basic we teach it to children. On Gliese 436b, ice remains solid at 800 degrees because gravity compresses it so thoroughly that temperature becomes irrelevant. Your body wouldn't melt, wouldn't boil, wouldn't vaporize. Instead, you'd crystallize. Every cell, every drop of blood, every tear, locked into a burning lattice that shouldn't exist. You'd become a statue of impossible ice, frozen solid yet hot enough to glow red, trapped in a state between liquid and solid that defies every rule matter is supposed to follow. This is what the universe has waiting in the darkness. Worlds where water burns, where ice refuses to melt, where the familiar becomes alien and the fundamental rules we've depended on for all of human history simply don't apply. Gliese 436b proves that our understanding of matter itself is incomplete. We've built our entire civilization on principles derived from Earth's specific conditions of temperature and pressure, assuming they represent universal truth. But they represent only a tiny subset of what's possible. Somewhere in the constellation Leo, 30 light years away, exists a world that makes a mockery of our chemistry textbooks. A planet where ice and fire are the same thing, where water crystallizes at temperatures that would incinerate any life form we've ever ever known. And somewhere on that impossible world, if anyone were foolish enough to go there, something that was once human stands frozen in burning crystal, asking a question without any sound. What else is physics hiding from us? If you want to see more videos like this, click the video on screen now and make sure to subscribe.